Everyone. I would like to say once more that I'm really happy to be here, and we are enjoying Barcelona, and we are enjoying to be together with you. And I'm really excited about the future of this project. So today I will talk to you about, I give you some introduction to acoustic characteristics of Turkish music. That is, mainly I will make you listen to some examples and comment on those. I will review my past work and also talk about the task list of a Turkish team in the project. So you will have an idea about what we will be doing in Turkey in the next 5 years. So by the way, I recently switched to Bahçeşehir University, Istanbul. So for a short introduction to music, the first question we have is, in fact, how to refer to it. Turkish music is very general. It would include pop, folk, rock, for example, Turkish rock. If you would go to Turkey and talk about Turkish music, some people would understand Turkish pop music, for example. And some people would understand Turkish folk music, and some others would understand the traditional music. And should we make a distinction between the folk and the classical? And there is a discussion going on here. If for example, the current way of considering traditional music is as if there are folk music and the classical music. And they even write the notation in a different way. But the musicologists are now discussing that they should be united, and there should be a single notation used for both of them. There should be a single music. And actually, when I talk about Turkish music, I always have difficulty in naming it Turkish. For example, I have Greek friends and all those people, and actually, how much Turkish is Turkish music? To me, I don't know. I mean, maybe it's better to refer to it as Ottoman. But then what is the boundary of Ottoman? I mean, if you talk about Arab music and Ottoman music, how you put the boundary of that, that becomes difficult. This is just to say that there is some fuzziness there in terminology. My preference, usually in papers, is Maqam music in Turkey, because there are so many similarities of Maqam music in Arab countries or in all those countries. It's hard to put a boundary to Turkish. And actually, there are many people who have contributed to this music, like Yorgo Bacanos, and should we call him a Turk? So my preference is Maqam music in Turkey in general. Now, I think to start with Tambour, to listen to this music and understand music is a good point, because just from the start, just by looking at the tambour, it gives you some idea about the music. I want to show you, I hope you can see the fretting on this instrument. They are irregularly spaced, and there are so many of them. I mean, as if you would continue to add more frets, it would come fretless. I think, to me, that speaks in this way. I mean, the tuning is not like the Western tuning. And in addition to that, maybe the musicians add more and more frets. I mean, there are too many frets here. And maybe they also have some confusion about tuning. I mean, maybe everything is not that clear about tuning. So this picture speaks to me in that manner. When you refer to books, instrument books, for example, or tambour construction books, you would see some drawings like this. And all of these drawings are referring to the theory, in fact. For example, this one assumes there are 24 notes in an octave, which is the accepted theory today. And you see also the note namings. We don't have do, re, mi, fa, sol, la, si, do, but we have one specific name for each note. And if you would have the octave of that note, it has a different name. For example, Rast and Gerdaniye, there is one octave in between them. So we don't have high Rast or low Rast. We have some low versions, but actually there is one name for each fret or each note. And let's listen to the sound of it and how they play it. We cannot see the fret, but there are so many frets here. So you see there is one difficulty, that you have so many frets and you have to be precise in moving. So the art of playing tambour, in tambour you play the whole melody on a single string. You don't switch strings. So you have to be precise in placing, moving from one note to the other. That is, you have to be precise in tuning. That is the art of this music. And there is a bowed version of this instrument, though it has a different shape. Well, the construction is different, but this is called the bowed tambour. And this here, the pitch space is more continuous. And because you have a bow, you can make really nice glissandos. It becomes like a fretless instrument. So here in Turkish music, I mean, the issue of fret, having so many frets and fretless, I mean, it's also, it's hard to put the boundary, I mean, because if you really put so many frets, you get close to fretless. Now, tambour is sometimes considered as the piano of Turkish music, in the sense that it contains all of the notes, and you have frets for that. So it's an important instrument for us to study the tuning or the character of music. But there is one difficulty in the acoustical form, I mean, in terms of acoustics, to analyze it. I want to show you one example of that. So I will play you the famous tambour player, recordings from 1915. This is spectrogram. Now, the interesting thing in spectrogram is you would see that low harmonics doesn't have energy that one would expect to see. For example, if you look at, I don't know, this point, the end point, you see that the higher harmonics have higher energy than the lower harmonics. And this is, well, explained to me by some instrument maker, that since you don't have a hole in this body, you don't have the Helmholtz resonance, which I don't know if this is true explanation. But by nature, if you look at those sounds, you would see that in many cases, the first one or two harmonics have low energy, and the higher ones have higher energy. So looking at the spectrogram, you can assume that, well, pitch detection here has some difficulty. So it would have been so nice if we could analyze it so easily, because tambour is a good reference for us, being fretted. Now, the other instruments we have, the fretless instruments, kemençe, oud, ney, and singing. Ney is the flute-like instrument you see here. But why do I name it fretless? Actually, in Turkish music, you open the holes in half, in thirds, and you move your head to play with the pitch. So it becomes like a fretless instrument. So, for example, a master musician is a musician that can play, well, if you would move, let's say, one or two of these holes somewhere and give him a wrong instrument, he would be able to play it in a right way by changing his head's angle, the angle of blowing. So this can be considered as a fretless instrument. We have another fixed tuning instrument, the Kanun. So you have to tune all these strings, that means you have fixed frequencies. Because, well, having fixed frequencies or not fixed frequencies, this is a discussion in Turkish music. I mean, certain master musicians would say there's no limit to the number of notes we use. I mean, we make transpositions, and then you don't find exactly the notes in a scale. I mean, if you shift some of the scales, since the intervals are not equal, you will end up with infinite number of notes, they say. But here, if we have an instrument like this, it's finite. But still, you see, these are called mandals. And these are very precise to change in small steps the tuning. So if I would show you an example of that, how they play. So, for example, this guy is Greek, and you would see, time to time, he plays with these mandals. Sometimes for effects like glissandos, sometimes to change the scale. For example, if to move from one makam to the other, or from one scale to the other, you would see them immediately change a few of those. I mean, he would jump and set those, set up the scale, and continue improvising. Well, the difficulty in analyzing this instrument is, well, he has two hands, and he can play it several notes at the same time, and he can make sweeps or so. So this makes it also difficulty for pitch analysis. And I want to also show you the ensemble playing. So this is rather modern. The way they play is rather modern, but let's see it. So they agree on playing the tune. They look at each other. In the other parts, they would again look at each other and make small improvisations. So actually, he makes accompaniment of his taste, not planned. And actually, this is not the actual usual way of playing the wood. He makes accompaniment with the bass. So this is the way. This is the reason I told it's modern. But well, even though we refer, oh, okay. Let's listen to it. So even he plays chords. So we tend to refer to Turkish music heterophonic or monophonic, but we see this in the actual setting. You have so many sounds, so many improvisations, one line going inside of each other. So actually, it's not that obvious and easy to study the pitch of it. So we can say studying pitch and rhythm in such a context is very complex. We have fixed tuning instruments we could study, but Tambour and Kanun, but they are hard to study because of the difficulty in acoustics. But we picked the simplest examples to start with to study the tuning of this music. That is monophonic recordings of ney, kemençe, and the easy to analyze examples. And I did a little bit of work with the rhythm analysis. I cannot even call it a work, but you will see some examples. So, but we have a friend here who did some work on rhythm analysis. He will explain us further today. So I started working on Turkish music in 2007, and here is our initial. Here was the initial perspective. I still keep some of this perspective. When I started learning about this music and studying this music, I have seen, one obviously sees that there is a mismatch between theory and practice. For example, on tuning, you see immediately there is a mismatch. And I said, as an engineer, it can be one of the good goals I have to provide a bridge between theory and practice. That is, by measuring, I can provide more information to theoreticians to correct the theory. And the instrument building, currently, the way instrument building tradition continues is from the master to the new instrument builder. So you want to learn the art of making an instrument, you go work with him, and they use templates. And for example, if you would put frets on a tambour, they would use something like a ruler where the frets are located. They wouldn't measure or put on the paper the centimeters or so, but they have templates. So it's copying templates. But, well, I question that in the sense now everything is changing. I mean, there is this digital instrument building, instruments are changing. So to be more flexible, we can give them some tools like tuners, for example. If the instrument makers could be more flexible by using some tuners or so, maybe they would end up with new designs. And also, I think it's important to come up with some educational tools. With educational tools, I don't mean that using just a tool you would become a master of a musician. But education can be at different levels. For example, someone interested in Turkish music can learn more about the music using those tools. Or a master of Western music can use those tools to learn more about Turkish music. So I would like to develop some tools to help people learn from a recording. So just load the recording and learn from it, or at least improve their understanding. And of course, we have the targets of music information retrieval applications, where we want to do automatic transcription, segmentation, all sorts of things. And what we started with is we targeted the stars, and we wanted to hit on the moon. So automatic transcription is a difficult goal. We all know that. But we can target that, and actually you will see in a minute that that problem itself includes most of the problems we discuss here. We have to study one by one to be able to transcribe music. So for transcription, we need notation, right? We need to know about notation, how they write this music. So in early times, in 13th century, they would write music in this way, which is like text. Again, in 18th century, you will find a notation of this type. It's again like text. So there was always some parallelism between language and music. So as you write the sounds in language, in text format or with characters, there was a tendency to write a notation, the notes, like text. But there was one foreigner, Albert Lubowski, who visited the Ottoman palace, stayed there, studied music, and he is the first one to use Western music to write down this music. And when he tells about it, he was the only one in the Sarai to note down music, to write down music. And it's by his help that we have some information about the music of that time. So there is always this question about if we should note the music, I mean write down the music, or not note it down, but pass from generation to generation by memory, which on one hand makes it alive. I mean, it changes in time, it evolves in time, but also you may lose it, because if it stops for 2 generations, then you don't have any information about the past. So this is, I think, a good example that notation may help us. But at least this century, we started noting down what we play. So this is the notation we use today in 20th century. And it's adaptation of Western music, as you can see, Western notation, as you can see. What do we have as extra? Some different flats and sharps. Because in this theory, they divide the whole tone into 9 steps. And they don't use all of the steps. But you have a higher precision, and you need more accidentals to be able to notate this music. For example, you see this scale contains only a si bemol, which is not a bemol of half tone, but it's a bemol of only 1 comma. I will talk about the comma and the other things. So the current theory is 24 tone, and it's not tempered, so you see they're not equally spaced. The tones are not equally spaced. If you would put it on Scala, the keyboard would look like this. So you see they are not equally spaced. Some notes are very close to each other. And actually, out of these 24 tones, a few of them are very rarely used. So, and the traditional way was, well, the number in our octave, let's say in 13th century, 14th century, was 17. Then you will see that it's increasing in time. And this theory is a combination of Pythagorean tuning, 53 that, and Western music notation. So it's, they mix all together. Because, for example, the way they define these notes is by Pythagorean operator of finding the fifth of the note. But they say, okay, it's very close to 53 tet. So they make this quantization also. And they want to write it on Western music. So it's an adaptation of this type, but discussions continue. But I want to show you one movie where the sound is synchronized with the notation. So you can hear that the pitches are different from Western music. This was not automatically created. This is by hand, manually done. And you see we have all these trills and the things we are used to in Western music notation. And the sounds that would appear to you different to your ears are the sounds notated by these ones. But still, some of the sounds that appear without accidentals, they are not exactly at the positions of the Western music. They are slightly different. So, here is a list of problems to solve for automatic transcription. First of all, yesterday there was a function one of our friends were discussing about. The tuning frequency could be 44 hertz or 440 hertz or 438 or 442. Well, for Turkish music, it can be somewhere within an octave. I mean, it wouldn't vary only just a few hertz. So we have to first detect the tonic or the reference frequency automatically, and there are no fixed places for it. Actually, there are 12 different possibilities for these places, but you cannot specify them exactly in frequency because they are specified by the length of the ney, and this length of the ney is never measured exactly. I mean, but what happens today is people started using tuners, Western tuners. So they tune these flutes, the neys, these instruments, according to Western La or Sol or Mi. So I think this is changing music. So this is one of the reasons I want to come up with a tuner so that they have an alternative. So the second problem is automatic detection of the Maqam, because if you want to write automatically the note with correct accidentals, you have to find the Maqam, because Maqam defines accidentals on the stuff, and also it defines the scale. And the difficult part is, of course, the relation between the pitch curve and the corresponding note. First, we have to deal with this theory-practice mismatch. Theory specifying one frequency, musicians playing another frequency. There are ambiguities in notation. So let's say you look on a notation on a song, and you see that all the notes have the same accidentals. But due to being ascending or descending, the notes may change frequencies. And it's not only because of ascending, descending, but there may be some transitions to some other makams, and there are ambiguities. When you talk to a master musician, he says, well, in the ensemble, I have big trouble, because the newcomers, they read this notation, this ambiguous part, in another way than I do. So there is confusion for musicians to read, especially the notation with some ambiguities. And of course, there is some freedom and variety on note frequencies. So I may play one note a little bit higher than you or lower than you. And there are frequently use of ornamentations which make pitch quantization very difficult. And also we have the problem of rhythm analysis and duration quantization, which is also difficult. Now, we started with a simple architecture. We said, okay, rhythm is too complex, let's put it aside and just try to quantize pitch. So we start with F0 detection, of course. And what we will do about automatic tonic detection and Maqam detection will be through histograms. So I compute a histogram of pitch, and using that, I will detect the tonic automatically and Maqam automatically. Then I will use this information for quantization of the pitch, because it will define the scale. And also in writing to MIDI or in writing to notation, you would need the accidentals that would come from Maqam. And starting from the beginning, we really wanted to share everything, but we cannot share WAV files. So we said, okay, let's start with sharing only the F0 information. We hope that some other people would check our work, maybe inform us if there are some errors, and make use of that data. And when you write to MIDI, with using the current standard MIDI, you have to use pitch band for these different frequencies. So the F0 detection is using the yin. I think maybe all heard about it. This is a ready MATLAB toolbox. And we have put some additional filters like octave correction, filtering out low energy regions, continuity, blah, blah. And some of them are dependent on the music. For example, in Turkish music, I would expect everything to appear within 3 octaves. I wouldn't expect that to exceed these values. And also, I wouldn't accept large interval jumps larger than 1 octave. Normally, it would be only fifth, usually, the largest jump. So about these different tuning methods and also the naming of the notes. Now, there is a different mentality in noting the music. That is, let's say I have this instrument and this instrument at hand, and I play a melody with this one and this one. Of course, well, if you use the same gestures, I mean opening and closing of the holes, the frequencies would be different, of course. But in Turkish music, you give the same name. So the naming is more about fingering, not frequency. So close all holes, that is a rast, that is a sol. And it doesn't matter which ney you use. So this is something different. So, and I said there are 12 possible places or even more for the reference frequency. This is a list of that. So each ney has a name, and it specifies the length of the ney, actually. So it specifies this reference tuning frequency. And the most frequently used one is named bolahenk, because it's easier to accompany the vocal. Considering the ranges of the human voice, that is the easiest to use. But, well, in a solo setting, you can use any of these. So we mentioned about ornamentations. this is an example pitch curve. So this is the time axis and the pitch axis. And these are the theoretical positions of the notes. You see that this data is hard to quantize. I mean, there are so many ornamentations, glissandos, all sorts of ornamentations. It's difficult to quantize this information. So we said, okay, let's look at the distributional characteristics of this information. I know you all know about what's a histogram, but it's nice, I think, to watch how a histogram builds. So you will hear the sound, and well, this is the final histogram. You will see the whole let's say segment, but you will see how it's developed in time. For example, this kind of an ornamentation doesn't raise any peaks. So as soon as you have many ornamentations, your histogram gets kind of vague in terms of peaks. But this is something expected. So we had a vibrato here, and this caused enlargement of this peak. And this enlarged width for peaks is sometimes due to this note changing its character when it's played on the ascending or descending line, sometimes due to these ornamentations. So we would need some temporal information also to study well these histograms. But again, to start simply, we just used the histogram itself without any temporal information. So when I bring this plot to a musician, they were very happy to see it because they said there is something we have difficulty in describing in the Maqam music. That is they say Maqam is not only a scale, but how much you emphasize each note in a scale. So since this gives some information about the duration of the notes that has been played, this is useful. But also it's maybe misleading because you have seen that this very large peak was only played at the end. It's just you stay long there. So you need to understand the music to interpret it in a nice way. So we should also keep in mind there is the freedom of the player. One may, for example, there are two examples here. One musician plays this interval at this position, the other one plays it at this position. There are some variations. There is the instrument making is non-standard, we talked about it, and the way they produce it is also different. For example, for Kanuns, they first put the 12 tones that are the Western tones. That is strange in building a Turkish instrument. Then they put the mandals to further divide it into a higher precision. Actually, they build a 72 tet instrument because you have first the 12, then you put 6 mandals to control more details. But in Ney, that is a natural wood. I mean, that is a plant. So you tune it by ear or by tuners, which we don't want, in fact, the Western tuners. And also Tambour, again, by ear. I mean, there is no fixed position for the frets. And the number of tones in an octave, well, if you look at the historical writings, they mention about 17 tones, but, well, it's increasing in time. Beginning of century, 24, then 32, 48. We end up with 79 tones in an octave. So to me, it says there is a confusion. I mean, it doesn't tell me that there is a need for 79 tones. So to tackle the first problem of tonic detection and Maqam recognition, one thing you can simply do is you can shift a histogram and try to match another histogram easily. So this is what we did. Let's assume there is some reference you have for a Maqam. Let's say from 100 recordings you could get a histogram and set its position. Here it's set to 1000 just as a reference. Then given a song, you can shift its histogram and try to match it and find its reference frequency. And also while matching that, you can check how much it matches, and that will give you an idea about what Maqam it is. And this was also used for Indian music by you, right? And Paracordia, because, for example, in Indian music they also have this drone sound, where in their previous work they were tuning it by hand, so manually setting up the frequency of this tone. This can be done very easily, automatically, and it seems to work in that situation also. So how you decide about the, let's say, bins of the histogram? So we did it by trial and error and also looking at the theory. So this is the histogram of the same thing. This is more precision, this is higher precision. So you can imagine that I will be doing some picking on this data. So if I go too precise, there will be difficulty of picking. And if I go too low, then we will lose some of the important peaks. And so we decided to use the highest resolution in theory, in tuning systems, in theoretical works. That was 159. That is the main reason we use this resolution, because sometimes people ask me, why do you use this resolution? That is the highest resolution I see in theory. That is 3 times 53, which matches everything. So, and in our work also we use the comma, the Holderian comma. Holderian comma is mainly 1/53th of an octave. And the reason we use it, there's so large literature referring to it for Turkish music. We want it to be comparable. So we wanted that the musicians could take and have a look at these histograms and make a meaning out of that. So that was the main reason. By the way, I sometimes read about Arab music also, and I see that this Holderian comma or Mercator comma is usually referred just simply as comma. And when they refer to it as comma, sometimes they mean really the Holderian comma, very rarely. Most of the time they mean well, a slight change in frequency. So it's rather a vague concept. It's not when a musician refers to a comma, he very rarely refers to exactly the Holderian comma, but he means a bit. So you would see in literature they refer to it as Turkish comma or Arabic comma, but well, it seems that they all use the Holderian comma. I don't see a difference. So, well, here I said, imagine you can compute this histogram from 100 recordings. How would you do that? Let's say I have recordings in one Maqam. I need to first align them. They are everywhere. So this is a simple method to align all of those. So we have from recordings, you do all the work to get the histograms, and then we have to align all the histograms. The way I did was to take first the system. The system defines the frequencies of the notes. You can synthesize a histogram, not a real histogram, and try to match it with these. So we construct a template synthetically by Gaussian mixtures, starting with the system from the theory, then align all these histograms with respect to that, and then we sum them up to get a new template, and then do it a few rounds, and then finally we have a histogram template. So this was explained in that study. So how does it look like? In theory, for example, in Hölderian commas, one scale would, the Hijaz scale would be defined with these numbers. Then you can synthesize a histogram this way using Gaussian mixtures. Then if you would want to match it with another histogram, with a real histogram, then you get really nice plots like this. It was really straightforward most of the time. But of course, we are talking about the monophonic easy examples. Once you match the two histograms, you know the place of the tonic easily. So this is automatic tonic detection. And let's look at some examples. This is Maqam Husseini, this is Maqam Rast, and this is Maqam Sabah. And the reason I, for example, show Sabah is for this note, the theory and practice does not match. Even though there is a mismatch here, the histogram matching doesn't have big difficulty because, well, it's only on one or two notes usually, and the global matching is, well, the contribution of this kind of variation is not too high. And of course, if it's only a few points to the left or to the right, you can always correct its location looking at the peak's location. So these kind of mismatches do not create a problem in matching. And you see that most of the time, matches are nice. Different distance measures has been tested, and I tried to make some control tests. I won't go into detail of all these, but what I tried was to use synthetic data, which I know the frequency. The frequency was 110 hertz. And by using different distance measures on a database of 150 songs, I tried to find the tonic by using this method and looked at the standard deviation and the errors and everything. Well, to sum up with, in 150 songs, using these measures, we made 4 errors using Euclidean and cross correlation matching. That is, when they make errors, usually they find the fifth, I mean the second important note instead of the tonic. And I also did some tests on real recordings where I manually labeled the real tonic and checked if the algorithm gives precise results, and the errors were like this. Why do I give it in just numbers? Because, well, as I said, the location of the peak, I mean, if there is an error of few points, you can easily correct it by finding the peak location. So in our work, we use this city block, which is an easy to implement distance. Now, we can say we have the technology to tackle the problem measuring theory and practice mismatch, because now well, in the past, there was this difficulty. I mean, the theoreticians and the people practicing music, they know there is a mismatch, but how to study that? They would need to go one by one on these recordings and try to draw conclusions out of 5 recordings only, because they didn't have the tools. Now we have the tools that you can just dump, give 1,000 recordings from one Maqam, and you can get a histogram out of that. And so we did a study that we took really good examples of this music that no one would criticize, and looked at the histograms and plotted them together with the theories. So on top, you see the theory that is being used, that is being taught in conservatories. So this is called simply the RL system, or all these names. And here you see these indicate the locations of the note with respect to tonic. The tonic is at 0. So the first interval is defined larger than what is played, actually. And we can, by looking at this graph, we can also compare several propositions, several theories. And you can see also, this is almost sorted in time. Well, once you recognize there is a mismatch, the new theory tries to add another sound or modify the sound a little bit. So it's like the theory is converging to practice in time. And of course, by automatically tracking the picks, we can create the Scala file and play on a keyboard. And this is also implemented in Tarsos, our Belgian friends. You can use their tools. And we did a work with our friend Kemal and with 2 other authors by comparing Western music theory, the 12 TETs only, and also these theories. So if you are interested, you can go to this paper and have a look at histograms of the most frequently used makams. And this is, for example, Maqam Hüzzam. And the match with the Western music, you see there are exact matches only here. And you have differences. And if you would shift this one, just 1 comma, the musicians would hear that. Because the intervals, they can hear precisely the intervals. So what is missing here is we need to, in fact, separate descending and ascending lines, because there is some change in frequency for some notes. So we have to, let's say, do some future work, some additional work, to get separate histograms for descending and ascending lines. For example, here is an example. At some positions, if it's a descending line, the musician tends to lower the frequencies of the sounds. You can observe it from here. So the Maqam recognition, how successful it is, just to look at the overall numbers. So if you take 9 most frequent Maqams, that is almost 75% of the repertoire. And if you do some control tests, so this is distance measure is city block using L1 norm and test method with leave 1 out, you would get some measures around 67, 68 in general. This is just using the histogram, which is really simple. I mean, this method is simpler. I never claimed that this should be the way to go for it. The reason of using pitch histograms was to understand the tuning, also to study tuning, to study automatic tonic detection. It helped all these, but we can do much better. Actually, let me jump to this one. It's highly open to further improvement, I think, the Maqam recognition. First of all, we need to, well, it's better to do some hierarchical classification. That is, some Maqams are confused in this work. You will see, okay. You can see it maybe. Here, there is a plot of confused Maqams. Well, in this test, this histogram is confused with the other histogram, which is okay. I mean, they match because there is only difference of 1 or 2 notes. Yeah. But if you had a hierarchical classifier, you could make a large group with these 2 Maqams, and then if they are different only at this region, you can further differentiate it at this region. And I think that would be more successful. And we need to add temporal information. There are 4 examples here about Maqam Hüseyni. From Maqam Hüseyni, this Taksim is a solo improvisation. You see the pitch variation. So this is a mellograph. It's not a histogram, it's a mellograph. So what you observe here is in each of the solo, the musician starts at the range and he plays around this note. And then he moves, he makes certain moves. So there is an overall movement of the pitch curve. So this is what they call seyir. And what is interesting here is when you talk to a musician, they would say, well, seyir is most important. And that is the melodic progression is most important. The scale is only 10% of the Maqam. And when they try to teach improvising in this Maqam, they actually try to teach this global curve. They would explain you, okay, start playing around this note, and then you would go down to this note, and then you would move to this note, and then you make the conclusion. And we can really observe it on the melograms. So why not use it for classification? So this temporal information, we should derive some feature and add into the classifier. And really, when they describe, the musicians describe, they vaguely describe it. They describe it as if they describe how you go from here to some other point in the city. I mean, go to this part and then turn right. And so this is the way they teach a makam. And, well, I hope also that this may help learning the music. Because I was mentioning about educational tools. Why only use description about the path? Also have a look at the path. And actually, this is something we wanted to do also, using the spectral features. At some point, I contacted Emilia because, well, I don't want to do everything with pitch analysis. I want to use spectral features. So this is some potential further improvements that can be brought to automatic makam classification. So what is the human performance? We don't have any measure of that. Well, for Turkish music, you don't have any measure of human performance for any task. Actually, for rhythm detection or for makam recognition, we don't have any perceptual tests. Nobody works on that. I think at some point we will have to do some part of these tasks. And maybe you are expecting that all the Turkish people know about makams and they can discriminate the makams. This is not the case. Average listener, you would ask them, it's by chance. I mean, they really don't know about makams or so. I mean, they listen to prayers every day, but they wouldn't be able to tell you it's from this makam or that makam. It's only those who are interested who can spot well, maybe around 60% the makam. But professional musicians, they are close to 100. And this is what they tell to me. I didn't test them yet. So actually, I feel I have to question all they say, because I can easily observe some of the contradictions. Or I don't know, maybe contradiction is a way of stating that. I mean, there is nothing really concrete. If that is the case, then it's normal that you have contradictions in trying to explain that. You always go over the real thing, you go around it. Sorry. So let me show you an example output of the transcription system. So this is not the transcription system, but this first, let's say you had a notation, I mean a segment to play, and if you would look how it looks on the mellographs, you would see that you can spot some of the notes, like the G's repeating here is here, but there is an extra small note. Should you note this or not? That is always a question in Turkish music. In Turkish music, notation is considered more as a summary than putting every detail on the notation. We don't really put every detail, and so how should we control that? One of my dreams was to make it scalable. I mean, if we could have a scalable transcription system where you can play with the amount of detail you put in notation, that would be good. So you can observe some part of the data is confusing, and currently our system, which has problem in duration quantization, ends up with something like this, which is too detailed. You see these are sharps of 1 comma. So we need some filters to correct all these and go further close to a summary than noting every little change in pitch. These two have no relation. Sorry. I should have told you that. These two have no relation. But it's not usable. What we have now is not usable. So, but we have just the last steps. So, actually, how about the time? 10:30. So I talked 1 hour? Okay. Should I continue, or do you have questions? Just to take a break, because 1 hour of listening to continue talk? Maybe you started sleeping. Any questions? Yes.
I can ask some questions. Yeah, I'm interested to know how do you think that we could evaluate this kind of transcription system? Because I mean, you talk about different level of details.
Yes.
You include ornaments or not.
Yes.
If you simplify, what kind of transcription system do you think musicians would like to have or would like to?
Yeah, testing is something to be discussed. I mean, it's not that easy, not straightforward. Well, I asked my PhD student to get some notation from musicians and to try to find a metric that defines the distance between these notations, and also go to analyze a few samples. I mean, comment on them. I don't know if there is a way to have exact numbers about the quality of an automatic transcription system. Well, if you know, if you have suggestions, please tell me. Well, what we can do always is to use synthetic data, but I mean, that is always questionable. I mean, that is one, you may have notation, you produce a synthetic output and then analyze and get the output and compare the two. But this will be only a synthetic test. Real test would always need to include musicians. And our first observations was that there is a difference in musicians' notations. And how to get a ground truth out of that I don't know. That is a musicological problem. I have to discuss with the musicologists. But if you have suggestions, I'm open to those suggestions.
No, because I guess we have the same problem in flamenco music where you have a lot of ornamentations.
Yes.
If you really transcribe them or not.
Yes.
And then if you simplify them, how do you know this? I mean,
Yes.
I guess there's two levels of transcription. One would be including all these ornaments and then simplify, and both have to be separately evaluated, I think.
Yeah, possible. Yeah, yeah. Actually, this is an open discussion for me. I don't have concrete ideas for that.
And then you didn't mention singing. Do you have
An example of singing? Let me show you.
or at least do you have some experience transcribing sound?
Let's look at this example. Well, there are typical ornamentations in singing, like the vibratos and so, and it's quite difficult.
Is it difficult to distinguish ornaments and vibrato?
Well, we had a rule-based system. In a rule-based system, we could detect the vibratos, but well, the main difficulty was with the glissandos or glissando plus vibrato. I mean,
vibrato is also a very specific issue, I think, in Turkish music, because depending on the style and on the period and on the teacher, you would get answers like no vibrato, it's wrong, or this style of vibrato or that. It's very dependent on the style and on the.
Yeah. Well, in terms of signal processing, we have difficulties when there is vibrato on an ascending or descending glissando-like points. Just listen to a short piece. So, well, it's like, oh, this is smooth. So, have to find the notes corresponding to that. We didn't separate instruments and study one by one. Since our system was really simple, I mean, this is just the beginning of a real work. We didn't look separately at the instruments.
And then my last question: if you had problems with noisy recordings or, historical recordings which are.
Yes. Well, it differs from instrument to instrument. For voice, the pitch method we use is developed for voice. But here, this one is noisy and old. But you see, this is a synthetic version of that. And you can hear it in parallel. And it sounds most of the time correct. For voice, it's easy, but for tambour, it's terrible. And noise plus these acoustic problems of tambour, we have troubles. The flute-like instruments, ney, is further easier, but there you have this. They have the nice glissandos, and it's never like a staircase. It always goes one from the other. And also Kemençe, I had shown one little example here. Okay, so this is, I mean, this is what you would have on a Kemençe. I mean, an ascending and descending line, and how to note that, I don't know. Well, our system currently fails at these positions. Any other questions we have? So as I told you, I didn't do any real work on tempo detection or so, but I wanted to check. So the simplest method we have for tempo detection is get an onset detection signal and then find the periodicity in that. So the autocorrelation function of the onset detection signal. So this is the autocorrelation function, and I would expect to get some peaks to show the periodicity. Here I could see one peak, but I make you hear those examples. So well, here the method should give me a peak to observe the periodicity. And the way they would count it is, so I mean, it's even difficult to count, and it's moving. So if you would spot it by hand, it should be around this region, but you don't see any peak or so. Another example maybe. Only you start seeing a peak if you have some percussive like thing that is repeating. I mean, if the sounds get more percussive, then you can observe the peak. The regularity starts to show up. And well, there is a wheel I reinvented, the beat spectrogram. So looking at this, I said, okay, I should look at the time variation of that. How do I do it? Oh, it's like a spectrogram. Let me make a spectrogram. So you take this and make spectrogram out of that. And I said, this is a nice representation. Then I figured out in literature they refer to it as the beat spectrogram. So this is a beat spectrogram of a song. And normally, as in a spectrogram, you would see harmonics. You would expect to see some regularities where you would detect the main period somewhere here as like the lowest harmonic. And when you look at this figure, it's as if there is something hidden by noise or some variations. We can maybe observe something. So I said, can be used as a visual tool, but hard to design a robust algorithm to perform automatic detection. And here, what you see is a change in, let's say, beat, right? Can you observe it? So here, the period is larger, so it should be slower tempo. Then here, it's a faster tempo. And I will play you the beginning and end of it, the same phrase. Let's see if you hear the tempo change. This part. Maybe it's something like this. Maybe this part. A bit faster. So, yeah, again, in maybe educational tool, or it may be nice at some point to look at this, but I don't know how one can develop a robust algorithm of processing this. Andre will talk more about this.
Yes, it's also unfair because it was not even.
Yeah. Okay. But you would expect to see some regularity, right?
Yes.
So maybe I can leave the demo to the end because we can. It may depend on our time. So this was about the past research. Now I will try to explain you the further research we want to do within the Compmusic project. A long list. But well, everything is so much related with each other. If you want to, for example, do automatic transcription, you have to go for rhythm analysis. And if you want to check how things work, you need to do some perceptual studies. And you would see that one interprets music different than the other musician. So all are interconnected somehow, and one feels like we have to do all. We have to be active in all. So here is the team showed up yesterday here, including me, and we have a musicologist, Okan Murat Öztürk, who is really from the tradition. I mean, he's a good musician, he's a good musicologist. So that makes up the team, which has the load of this. So I want to go one by one, so that we can really discuss here. I mean, if there are points you see not so relevant, feel free to bring it, and we can really discuss it. Or should we further enlarge it or not? So the tuning analysis, I love it. I see it as low priority because we have done some work. And one of the points was, well, we were studying the complete song. But the complete song includes many transitions or so. And many smaller units change. And one idea is to study those smaller units separately that are pentachords or tetrachords. For Maqam, the first tetrachord or the pentachord can be recorded by a musician. One can ask to the musician to record it, and we have that database actually. So we have a database where the musicians were asked to play each tetrachord, and you have several musicians. So we can do a small work on that. And I mentioned about the ascending and descending lines separately. This may be comparatively important because we will face it in automatic transcription anyway, that changing of these frequencies. And also there may be a perceptual approach to study tuning. I have been imagining a system that where you can, let's say, have a synthetic signal created by a scale, and you can ask the musician to change the frequencies to find the best scale, and then at least you have an understanding of what they do just by hearing. Because playing an instrument, you have certain physical constraints, and it may force you to play in one manner or so. So this is one other potential future work, but as I told you, I see it as low priority. We will do it as we have easy access to data, or we have to do it. Now, what is more important for us is melodic progression analysis, because, well, you would hear from many musicians, they would say here, the melodic progression is 80% of what Maqam is. So actually we want to study it both in starting from symbolic data and also starting from audio data. We plan to start with driving some statistics like n-grams, suffix trees, some sorted arrays. So we already have a symbolic data. Starting from symbolic data, we will start with trying all the existing methods in literature for melodic analysis. We have to have a method for melodic phrase boundary detection. So still I'm reading the literature to decide about what to test. Maqam transition detection and building a model map of transitions. This is an important topic because actually a Maqam is, well, in an improvisation you never play in that Maqam. So there are certain possibilities of transitions. You can go and you should go. I mean, they would expect you to do it. Even you would see musicians telling you that the solo improvisation is an art of makam transition. I mean, how beautifully can you move from one makam to the other? So starting from symbolic data, can we spot those transitions? And can we build a map of how they move from one makam to the other? And also, one important part of makam is typical phrases. So, for example, when the musician talks about seir, he says you should move, you should play in this note, then move to this note, then to this note. And the way he describes it gives you a feeling that you should be able to listen to the whole recording to decide the makam. But that's not the case. I mean, when you see them spotting a makam, immediately in 5 seconds, they say, okay, this is that makam. And how do you do it? You haven't seen the whole progression. So it's through the typical phrases. So these typical phrases we want to detect automatically. Of course, we will start by hand annotation. And from that data, we will try also, that will be our ground truth. And the problem here, the difficulty here is, well, typical phrases can appear in a solo recording during a transition. I mean, let's say you start with makam A, and then you go to makam B, and in that part you play the typical phrase of makam B. So if you would take the whole recording and try to find the typical phrases, that typical phrase is coming from another class. So we need kind of a segmentation on this data. Then we can study this problem more easily. So this was about the symbolic part. And we have to do similar things in audio data, right? To be able to do that, we want to be, again, the same thing. We need to study the effect of melodic progression on tuning, because actually in this, there will be an ambiguity, or there will be a difficulty in deciding if a change in pitch frequency is due to a descending ascending line type of thing, or due to a makam transition. There will be those kind of difficulties. So we have to find an automatic way of melodic phrase boundary detection. And again, building that map of transitions on an improvisation. Again, detecting the typical phrases, just starting from the pitch information. And also we want to compare symbolic and audio data. So we want to build a parallel data and study all these tasks in parallel, and also compare and evaluate how they are related, the symbolic data and audio data. So any comments on this? Because this is the first task, this is the most important task we have for the next year. And yes?
I have one question there. Is there a standard collection of MIDI from?
Well, we have, it's not a standard, but we have the collection, the only existing collection.
How big is it?
1,500, so? Yes.
Yeah, we did the note by hand.
Yeah. Well, actually, yeah, this is a special database he will talk about. I will just say one phrase, that is, you can have the MIDI created from notation. I mean, you have the notation, but the data they have is special in the sense that it was corrected by hand. All those little changes in pitch.
So it's very accurate.
Yes, well, it's the most accurate we can get on symbolic data.
And have you considered like merging or aligning performances to MIDI?
Well, we will see an example. I didn't, but since Andre was in some place they had the tool, we will see the performance of that. And any other comments? Any comments? What do you think? Okay. At some point we need to do some ornamentation analysis, as you mentioned. I mean, how to automatically segment and classify ornamentations. It seems that, well, several groups will have to work on this. I mean, I guess Indians and also Arabic. I don't know about Chinese, but we will all have to work on automatic segmentation, classification, ornamentations. And also studying the link between the main melody and the ornamentations. I mean, you are given the notation. Where should these ornamentations happen? And is there a way to find the systematics of that? We will have to study structure and form. So, for example, we need to automatically detect repetitions within the same song to find verses and so. Automatically detecting the rhythm changes, the weighting we could see, that the tempo change, those kind of changes we should be able to detect. We should be able to detect the form because, well, this is very much linked with the rhythm. For example, in some forms, it's precisely said that, okay, in A you play one sort of rhythmic structure, and when you go to say, part B, you have to play another rhythm. Probably this is also for Indian music. So rhythm and form is strongly related. Yeah. So, and also form and melodic progression, how they are related. This is a question I ask myself all the time, because in an improvisation you see this overall movement of the melody line, that is the progression. But if you have a form that is repeating patterns, A, B, A, C, whatever, this changes. The global pitch variation has a different structure. So how is the relation between the form and this overall melodic progression? Andre will be talking about rhythm analysis, but just to name what we will have to do is automatic detection of onset, beat, and usul corresponds to the rhythmic structure for us in Turkish music. And we can work both on audio data and symbolic data. I mean, given a MIDI, can you define the rhythm of that? And also, this is Andre's idea to link low-level and high-level rhythm parameters and have a structure. He will talk about this, so let me skip this for the moment. The other things we want to work on is interpretation analysis. By that I mean, okay, there is one musician playing a song in a certain manner, another interpretation, and is there a way to classify those interpretations or classify some schools, have to study these interpretations. I don't have an exact idea about how to tackle this problem, but there is this issue about interpretation. So we can easily build some data of the same song played by different musicians and start working on that. And so, well, let's say you are given only MIDI. Some of the tasks we do with audio will have to be done also for MIDI, so Maqam detection from MIDI. Already maybe we will see some results. And also, well, when I started working on this topic, I have seen that it would be nice if we could give some toolboxes to people, because I see lots of people use them and it makes you connected to the community. So and for MIDI, why would we need a MIDI toolbox for Turkish music? Because we use all these pitch bands also for these notes. I mean, we have the symbolic data, and when we apply it on MIDI, we tweak MIDI. So all these tweaks could be maybe made easier and more standard for Turkish music. We will think more on it. And we plan to study the link between the hand-corrected MIDI and uncorrected data. Why are those corrections appearing there? And that will give us an idea about the character of the music. And the difficult one is study the path from concept to sound in an improvisation. But this is what they teach by oral education. I mean, the regular way of teaching the traditional way of teaching this music is oral tradition, and they actually target to teach this. I mean, you have the concept of the Maqam, how you improvise on a Maqam, and we can try to go deep into that. And of course, we will be doing cross-cultural studies with all of you. I mean, I think maybe 70–80% of the tasks I'm talking about can be mapped to the Indian music. So we will be doing these cross-cultural studies. So this ends up the talk. I can show you a little demo of the software, or I can just take the questions.
You can do it in the afternoon.
Yeah, okay.
You can take a break and then.
Yeah. So,
Yeah.
yeah.